Industry has rocket launched radically ahead of the preparatory pieces.
A lot of the time, firefighters, fire agencies are just expected to kind of figure it out.
Are electric vehicles safe? In a world where technology propels us into the future, one question reverberates louder than ever. Are electric vehicles safe? From regenerative braking to autonomous driving capabilities, electric cars are not just changing the game, they're rewriting the rulebook. But what about the naysayers who question their safety? It's time to debunk the myths and arm you with the knowledge you need to know about the electric vehicles. So if you've ever wondered whether EVs are safe or not and wanted to say goodbye to your old gas guzzler, you're in the right place. Buckle up because we're about to delve into the electrifying world of electric vehicle safety right here on our channel. In this video, we'll explore the cutting-edge safety features that are revolutionizing our roads. So stick around as we charge into the heart of electric vehicle safety. Let's get started. Safety of electric vehicles. In this modern age, the way we view transportation is undergoing a seismic shift. One of the most prominent innovations in this field is the advent of electric vehicles. These vehicles, powered by electricity, have quickly become a symbol of the future, promising a more sustainable and environmentally friendly mode of transportation. However, as with any emerging technology, concerns about their safety linger in the minds of consumers. In this comprehensive exploration, we will delve into the safety aspects of EVs, comparing them to traditional gasoline vehicles, scrutinizing crash tests, evaluating safety features, and examining battery safety. Crumple zones and structural integrity of electric vehicles. Electric vehicles represent a paradigm shift in the automotive industry, not only in terms of their eco-friendliness, but also their commitment to safety. One of the standout safety features that set EVs apart from their traditional gasoline-powered counterparts is the design of crumple zones. Crumple zones are a pivotal element in the safety architecture of electric vehicles. They are meticulously engineered sections of the vehicle, typically located at the front and rear ends, specifically designed to absorb and dissipate the kinetic energy generated during a collision. During a collision, the crumple zones in EVs crumple, as the name suggests, thereby extending the duration of impact. By increasing the time it takes for the vehicles to come to a complete stop, these zones reduce the forces experienced by both the vehicle's occupants and the passengers in the other involved vehicle. Furthermore, the clever engineering behind these crumple zones directs the forces away from the vehicle's occupants, thus significantly reducing the risk of injury. Low center of gravity. The battery packs in electric vehicles are typically located at the bottom of the vehicle. This design results in a lower center of gravity compared to traditional cars, which carry their heavy engines at the front. In most traditional vehicles, the engine's weight at the front end can lead to an inherently higher center of gravity. This elevated center of gravity increases the risk of rollovers, particularly in situations where a vehicle may be subjected to sharp turns or abrupt maneuvers. Such rollovers can be catastrophic and are a leading cause of severe accidents in the automotive world. However, in EVs, the placement of the heavy battery packs at the vehicle's lowest point has a transformative effect on the center of gravity. By distributing the weight more evenly along the vehicle's floor, EVs achieve a significantly lower center of gravity compared to their gasoline counterparts. This lower center of gravity reduces the likelihood of rollovers, making EVs notably more stable and less prone to accidents. The stability derived from the lower center of gravity is especially valuable when it comes to maintaining control during emergency maneuvers or navigating challenging road conditions. EVs exhibit less body roll during sharp turns, ensuring that the tires maintain better contact with the road surface. Instant torque and accident avoidance. Electric vehicles have an inherent advantage when it comes to acceleration due to their electric motors. Electric motors provide instant torque. In a gasoline-powered car, torque typically builds gradually as the engine revs up. However, in EVs, electric motors produce maximum torque almost instantaneously from a standstill. This means that the moment you press the accelerator pedal in an EV, you receive an immediate and substantial surge of power. The ability to accelerate rapidly and responsively is a game changer when it comes to avoiding accidents on the road. in critical situations where quick acceleration can make the difference between a near miss and a collision, EVs have the upper hand. For example, suppose a vehicle suddenly merges into your lane or a pedestrian unexpectedly steps into the road. In that case, the instant torque of an EV allows for rapid and precise maneuvers to evade the potential danger. Moreover, electric motors also provide strong regenerative braking capabilities, allowing for swift deceleration when you release the accelerator pedal. This regenerative braking, which converts kinetic energy back into electrical energy, enables smoother and quicker stops, further enhancing the safety of EVs in stop-and-go traffic. Crash tests and performance. Electric vehicles undergo rigorous crash tests to ensure that they meet the highest safety standards. Organizations like the National Highway Traffic Safety Administration and the Insurance Institute for Highway Safety subject EVs to comprehensive crash tests, assessing various factors such as front, side, and rear impact performance, roof strength, and head restraints. These tests offer a comprehensive view of a vehicle's safety capabilities. The outcomes of these tests often reveal that electric vehicles outperform traditional gasoline cars in terms of safety. Their structural integrity, as well as their advanced safety systems, contribute to better performance in head-to-head crash tests. We will examine real-world crash test results and statistics to support this claim. Advanced safety systems in EVs. Advanced safety systems integrated into electric vehicles have revolutionized the way we think about road safety. These technologies not only enhance the driving experience, but actively work to prevent accidents, making EVs some of the safest vehicles on the road. These safety features include 1. Adaptive cruise control. It is a standout feature in many EVs. This system employs sensors to continuously monitor the traffic ahead. It automatically adjusts the vehicle's speed to maintain a safe following distance from the car in front. ACC effectively reduces the stress of driving, especially in stop-and-go traffic, by handling acceleration and deceleration seamlessly. More importantly, it actively contributes to accident prevention by eliminating the common problems of tailgating and abrupt stops, two scenarios that often lead to rear-end collisions. 2. Lane keeping assist. Lane keeping assist is another vital safety feature in EVs. It relies on cameras and sensors to monitor the vehicle's position within its lane. When it detects the vehicle drifting out of its lane without a turn signal, it provides corrective steering input to guide the vehicle back into the lane. This technology not only reduces the risk of accidents caused by driver inattention, but also helps combat the dangers of drowsy driving and momentary lapses in concentration. 3. Emergency braking. Emergency braking systems are designed to detect potential collisions by constantly monitoring the vehicle's surroundings. If the driver fails to react promptly to an impending collision, the system automatically applies the brakes. Emergency braking can mitigate the severity of accidents and, in some cases, prevent accidents altogether. This advanced safety feature is particularly valuable when sudden obstacles or hazards appear unexpectedly on the road. 4. Battery safety in electric vehicles. Ensuring the safety of EV batteries is paramount, given their integral role in these vehicles. Electric vehicle batteries are equipped with multiple layers of protection to prevent overheating, damage, and potential hazards. 5. Battery protection. Battery protection mechanisms include temperature control systems, redundant safety features, and advanced cooling systems. These safeguards work in tandem to maintain the battery's optimal operating temperature and protect it from extreme conditions, ultimately reducing the risk of overheating or malfunction. 6. Battery testing. Battery packs in electric vehicles undergo rigorous testing to guarantee their safety and resilience. These tests subject the batteries to extreme conditions, including high temperatures and physical stress, to evaluate their durability and performance. The results of these tests provide strong evidence that the chances of a battery-related fire or catastrophic failure are exceedingly low, assuring consumers of their safety. So finally, we've busted the myths and unraveled the future of safe EVs. If you've got a burning AV-related question or suggestion, you can share it in the comments below. We have covered everything from crumple zones to advanced safety systems, so you're now well equipped to make an informed decision about the safety of EVs. If you found this video informative and it helped answer your questions about electric vehicle safety, don't forget to give it a thumbs up and share it with your friends and family who who might be pondering the switch to electric cars. Also, hit that subscribe button and ring the notification bell to join our EV community.